is on the y-axis. Y-axis is the tangent line on this point also minus a. But we can similarly comment upon. We are taking a0. At a0 is y-axis. That at a point also, these are the tangent lines which are passing through minus a0 and a0. This is y-axis, mu y-axis. This is parallel to the original y-axis. The shape of the curve is of question number 8. Okay. So this is how we have done this question number 8. Now let me talk about 9th question. Now question number 9 is of what kind? Let me check it. Now question number 9 is, what is it? Trace the curve. Okay, tracing the curve, 9th question. Trace the curve x5 plus y5 equals to 5 a square into x square y. This one. x5 by plus y5 equals to 5a square into x square y. Okay. So let me take this equation. So first, neglecting by 5. Sometimes we have to neglect. So there are two forms of the tangents here. Now this is odd term. If I replace, if I put x equal to minus x or y equal to minus y, will there be a change in this equation? Okay, this is minus, this is negative sign will be there, but this is positive because x square is there. So x square will be positive, but this is negative. This negative sign will be cancelled out. If I put, it means there is no change here. So in this equation, symmetric is in opposite quadrants. So with solution, let me find out. This equation is also symmetric in opposite quadrants. This is the equation here. Putting if first point, if we put x equal to minus x and y equal to minus y, then there is no change in the curve. Then there is, or the curve remains same. There is no change. There is no change in the equation. No change in the equation of the curve. In the equation of the curve. No change in equation of the curve. This is the point here. Try to understand. If I put minus y in place of y, in place of x, this is negative. These two will be negative. If I replace by minus sign, okay, then this minus sign cancel out with positive value. It means there is no change in the equation of the curve. It means the curve will be, therefore, the curve will be symmetric. Symmetric in opposite quadrants. In opposite quadrants. Simple logic. As in 9th question we did, or in 8th question we did, in 9th question also. Quadrants will be, there are different quadrants, the curve will be similar. I mean, symmetric. Then, second point. Okay, now neglecting y, once y, and what is, or first let me neglect s5. Neglecting s5 first, so we get y5, okay, is equal to 5a square x square into 5, or y4 is equal to 5a square into x square. That is y square is equal to plus minus under root 5 into a into x. Okay, so this is the value of y equal to y square is equal to this plus minus. Because this is y4 here, so y square is equal to plus minus this value. It means if I put the values, so what is the value of, then again square root of this whole value will be taken out. y square is symmetric here. Okay, so y will be there. Now let me neglect y5. Second point, this is first equation. We have obtained values of y will be plus minus 2 values. Means in both the quadrants of y you will have some values here. Okay, now neglecting y x5 we neglect, now y5 let me neglect y5. So we get the equation, given equation as x5 is equal to 5 into a square into x square into y, or xq is equal to y of 5 a square into y, or so this is equation, this is known as cuboidal ellipse or cuboidal parabola, you may say cuboidal parabola type. This is parabola here, y square equal to, so this parabola y square equal to 5 under root 5 ax whatever. This is parabolic type of question. This parabola will be in opposite quadrants here. This parabola plus minus negative value and plus negative value. This is parabolic equation here, one parabola type. So in this case, this is cubical parabola. Okay, this cubical parabola, we have to draw the question here. So x cube equal to 5a square into y. This is a cubical parabola. Or y is equal to, therefore, compare that y is equal to, from this equation, x cube upon 5a square. So, or x cube equal to 5 a square into y. So whatever values of y we substitute x cube and find out, then we will draw that figure. So what kind of figure? I mean that what kind of that we take the next marker. Okay, next marker is next marker is change the marker. Here the marker is this. So, what is the equation here? Y equal to here. So y is equal to plus minus. This is parabolic type of equation. Y equal to x and y equal to minus x. We have replaced this value. Now it means quadrant the function will be in different quadrants. A similar type of figure will be there. So these two equations, if I find out dy dx, then what is the value of tangent here, that we will find out. But before that, the cubical point, if we solve these equations, the different values for this y equal to under root 5 ax, and if I find value of x here, what will be the, if I put y equal to x in this equation, what will be the values? Y equal to, if I put y equal to x cube, x square equal to that value, then x and y can be calculated. What are the values of y from this? Y equal to under root 5 upon this. So if I putting y equal to x, putting y equal to x here, or if I put y 0, then x equal to 0, but y is 0 or x is 0. Okay, so if I, let me equate the smallest degree term of this equation to 0, what we will get? This will be equal to 0. Equating the smallest degree term, to 0. That means x square into y equal to 0, x equal to 0, x equal to 0, y equal to 0. This is the tangent line. Y-axis is the tangent line. Okay. And x equal to 0 is on the axis of y, x equal to 0. So the two figures are in case of x-axis or y-axis. So y equal to x. So what are the equations here? Let me, if I find out dy dx, what is the point? So if I solve them, these points, y square will be obtained under root 5 or something, and x square from this equation x cube was equal to, well, this was x5 equal to, let me first solve the value of x, then value of y. The points will lie that curve will intersect, because this curve is, okay, points are x equal to 0, y equal to 0. If I solve these equations, so y equal to, we found x5 by 5 be neglected, it was equal to y5 equal to 5a square x square into y by the value. If I put y equal to x here, suppose y equal to x, it means y minus 5 into a square x square. If I divide, let me divide by x square. So here x cube equal to 5a square into y. Okay, and if I put y again, y equal to x here, suppose on the line y equal to x, for this curve is symmetric in the opposite directions. So y equal to x, the curve is in the opposite directions in the first quadrant and third quadrant, opposite quadrant. Sorry. So x cube, if I put y equal to x here, x cube is equal to 5a square into x. That means x square is equal to 5a square. Sorry, this is 5a square. That means x equal to plus minus 5 under root 5a. Under root 5a. The value of x is under root 5a. And because x equal to y is also the same point. Y is also equal to under root 5a plus minus under root 5a. That means, what are the points here? Under root 5a. Y is also under root 5a, positive value. Okay, at this point, and then second point is minus under root 5a. Y is also minus under root 5a. It means this is first quadrant and third quadrant. The curve is passing through the first quadrant and third quadrant. And one second point was that, okay, and upon these values, y was a parabolic type of equation. That parabolic equation was there. So let me take next point here. So the curve is symmetric about symmetric to, and then we will shift the, if I shift this point minus under root 5a to plus 5a, okay, these points are to be shifted. Then what are the points? Okay, upon this point here, so let me draw the curve here for the under root 5a and plus under root 5a. So the curve will be that this is the line y equal to x. Okay, and this curve is passing through a point here at this point, which is, I'll just define that under root 5a. Here it is value under root 5a plus under root 5a. Both values same because y equal to x, this is the line. Y equal to x. And here is minus under root 5a. Minus under root 5a. X is also negative, y is also negative. Okay, so this is at this point here. What is the line here? This is oblique. X plus y equal to, okay, at this point, x plus y equal to, or x minus y, here it is minus y minus x equal to 0. This is the line here. Okay, at this point, so tangent is, this is oblique tangent. If I take this constant, so y minus x equal to y minus x plus a equal to 0. Okay, this is the equation at this point. For this point is parallel to this line. So if I find out dy dx, let me find out dy dx of this equation. What the value of dy dx? Then we can find out at what point this curve will lie. So this is the point at which the tangent at this point will make with the axis of x. That point we have to calculate. For that dy dx is to be calculated. Okay, so dy dx, if I calculate from this equation, so it will be 5x4 plus 5 by 4 into dy dx. 5 by 4 into dy dx, sorry, is equal to 5a square, which is 5a square, into x square as it is, d by dx, first step, plus 5a square into y as it is y x, with these two steps here. If I find d by dx, these two terms are the d by dx. So d by dx is these two terms, 5 cancel out both. It is x4 only. Let me take. This is y4 d by dx. Okay, d by dx here, and this one d by dx, so the minus sign, x square, this value into d by dx, a square is also there. A square x square into d by dx. Okay, this is equal to okay, these two values are there. This is 5 x4, 5 is cancelled out, so the x4 are taken. I'm just collecting the d by dx value. D by dx, tangent at this point, we have to find out if these two terms are there. This is positive to that side, this is twice equal to twice a square y into x, or x into y. Okay. Minus sign, if I take this that side, minus x4 there. This step is there, removed. So d by dx therefore is equal to twice a square xy minus x4 divided by, this is y4 minus a square x square. If I substitute the value of x and y and root 5a and plus and root 5a, this will come out to be, this is a square twice a square xy. So this value will come out to be minus 1. For tangent minus 1, tan minus 1, sorry, tan is minus 1 for 135 degree. This line is of 135 degree angle. This is of 135 degree angle. Okay, so this point is 135 degree. So the tangent at this point will lie, or will make angle this. Similarly here also, we will take this point to this point, and then another curve which is down here, this is known as parabolic bispherical to root 5a, that by 0. This is this curve which is parabolic type, and along this line, this is y equal to minus x, or y plus x equal to 0. Along this line there is a parabolic equation. Parabola is like this, because the value of x as it increases, y tends to infinity. Y tends to infinity. Okay, so y tends to extend to, when extend to 0, extend to infinity, increasing, then y tends to minus infinity. Again, the same type of question is there. Okay, here also, when extend to minus infinity, y tends to positive infinity. Because this is the linear equation. So along this line, this is parabolic type of equation. This is another curve in case of y square equal to be forward plus minus under root 5. Under root 5 is a, I think, because ax, under root 5 ax. So this is parabolic equation which is along this line. So from this equation, if I put x tends to infinity, y tends to negative, but this is from this equation. When x tends to infinity, y tends to positive infinity. Because x tends to, by x tends to 0, but x tends to infinity, y tends to minus infinity. This is that curve. And x tends to positive, x tends to minus infinity, y tends to positive infinity. This is along the line. So this is the question number 9. The shape of this curve is, I think, this one, because The shape is coming out to be this one. How this point we obtained from solving this equation, and root 5a and 5a. This is minus 105a and root 5a. Solving that equation we obtained. And if I solve this dy dx, if I find out, okay, that will give us the slope of the tangent at this point. At this point, this root 5a and root 5a, if I put here in place of x and y, we will obtain the same type of, because this is x into y, x and y is there, a square is there. So this value will come out to be minus 1. So dy dx is minus 1 at the point, at this one, under root 5a and root 5a. Okay, under root 5a and under root 5a. This is the point here. So tangent at this point is making 135° angle with the axis of x at this point. So this is shape of the question number 9th curve. The 9th question is having this kind of shape. This curve is having this kind of shape. Now question number 10th, let me talk about. Now again, this similar type of question is here. What is this question? Now here we have to talk about the 10th question is also of similar type. Trace the curve which is x6 plus y6 equal to x plus y6 equal to a square into x square y square. Alright. So this is symmetric to both the axes. The curve is symmetric to both the axes or about both the axes. Solution here. Here, first point, the curve is symmetric. Curve is symmetric to both the axes. The reason is because even terms are there, or powers are even of both the variables. So this one. Second point, let us talk about there is no, it's passing through the origin. It is passing through the origin. Or origin is lying on this point. It is passing through the origin. Passing through the origin. Okay. No asymptotes there because I just talked about third point. If I put y equal to 0, x value, that is not a point here. If I equate the smallest degree term, which is this one, 0, equating smallest degree term, equating smallest degree term, 0 to 0, we get here, what do we get? Then we will differentiate it and finding out second derivative equal to 0. From there we will find out that is there a point of inflection or not. Okay, so point of inflection 0, 0 is there or not. So degree to 0, we will get x square into y square equal to 0. Here x equal to 0, x equal to 0, y equal to 0, y equal to 0. It means these axes will work as tangent lines upon the curve. Okay, x-axis, x-axis, y-axis, y-axis. So this x equal 0 is on the y-axis, x equal 0 is on the y-axis, y equal 0 is on the x-axis. So x-axis and y-axis both will work with these, this curve. So what are the points we have to find out? If neglecting one x6 one time and one time y square, that will find out what the points then. So neglecting x6, first let me take, or y6, or first neglecting, let me take y6, we get the equation x6 equal to a square x square y square, or from this we will get x4, okay, minus a square y square equal to 0, or from this we will get x square is equal to a by. Now again this is a parabolic equation. Parabola, this parabolic equation is there. This is the curve x square equal to plus minus x equal to plus minus a by x equal to plus minus a by. If I put y equal to x here, okay, so the two lines are x equal to y or with x equal to plus y, y equal to minus y. So from this equation, you will get x equal to y and x equal to or y equal to minus x. Same value, y equal to minus and y equal to plus x. There are two or a times it is multiplied no problem. This is a times here is constant, doesn't matter. That line will work as a because the function is a simple this curve is symmetric in both the axes. Okay, and if I change minus x x by minus x by minus x, that is also possible. But then it will be symmetric in opposite quadrants also. Opposite quadrants symmetric. Okay, now if I find differentiation, of the double derivative, what is double derivative value? If I find out, that will give us the solution of this equation. So what is that solution? Now, so y equal to x and x equal to y. So what are the points here? Let me solve for points. If I solve it for y equal to x equal to this under root a by, so this is under root a by. No. x4 we found out, this is a by 1 x equal to under root a into y. X equal to plus minus under root a by. And if I put y equal to x here, it will be, if I put y equal to x, it will be under ax, or x taken common under x. If I take common, under x plus under a. What is the point here? How do we solve this equation? Let me solve these two equations here. So, how to solve these equations? The solution here. Okay, so this point is, there are no asymptotes here. For the asymptotes at this point, if I just because origin is lying upon this point, so no need of shifting this any point here. What is the points here? A upon under root 2, a upon under root 2. How it is coming out. So if I solve this equation x square, I have taken so under root a upon 2. If y equal to x, if I substitute, y equal to x if I substitute, putting y equal to x in the given equation, because this equation can give us symmetric group in both the axes. So if I put y equal to x in first, what we will get? We will get here x6 twice x6 equal to a square into x4 here. Is x4. This will give us x4 common. If I take x4 common, it will be twice x square minus a square. From this we can get that at y equal to x axis, what is the point on the given curve? So that we are calculating. So here, this point is there, x equal to 0, 1 point, and second point is x equal to under root a, because x square equal to, first is x square equal to a square upon 2. This implies that x equal to a upon under root 2. This is 1 point. Y will also be the same point, a upon under root 2. Okay, and at the line y equal to minus x, if I put, then it will be negative signs. So y will be with negative sign then. Y is equal to negative sign here. In the negative axis, if I put y equal to x in this equation, y equal to minus a upon root 2, x equal to minus a upon root 2. This is one of the points. Okay, so this is the curve. And then if I solve it for y, y will also give the same question. Yeah, same question is given to us. What is the figure here then? So the figure will be that y equal to minus x, y equal to plus x. The shape of the curve in this case will be because it is symmetric to both the axes. So this type of, this is the line y equal to x. Y equal to at the point, this is the point here. What is this? A upon root 2 and A upon root 2. This point is there. Similarly here. Okay. At this line, if I on the tangent line, which is just oblique to this, and this point, this tangent will make what kind of angle with axis of x, we will find out y-axis. And in this case, y equal to minus x is another line, because if I put y equal to minus x in the given equation, so that also will give the same type of question, because this is even term. So this figure, at this point it is this point is like this. In between this is passing through. Okay, so this point will be 135 degree angle, because if I find out dy dx and putting at this point, we will get the same type of question here. Dy dx will be minus 1. That means it is tan 135 degree. So this angle is theta equal to 135 degree here. Theta is 135 degree. So angle is 35 degree. The tangent at this point is making. This line is y equal to x. Here it is y equal to minus x. So in this equation, if I substitute these points, or if we have calculated substituting y equal to x in the given equation, we got a upon root 2 value of x. Y is also the same because it is y equal to x. Here it will be negative and positive, same values. So it is also a upon root 2. There is negative sign. Minus a upon root 2. X is y will be positive sign. A upon root 2 here. Okay. Now in this case, with y equal to minus x, if I put x positive, y will be negative. Y will be negative here. X positive, y negative. This is a upon root 2, and y is minus a upon this point here. Both are negative here. This is minus a upon root 2 and minus a upon. Okay, this is the shape of the curve in this point here. So how we can calculate dy dx? If I calculate, we will get this minus 1 sign. Okay, and this 0, 0 is the point at which line is no asymptotes here. No asymptotes.